Hello students, in this video we are going to learn about calculus. Differentiation and integration are the two parts of calculus. So let us get started with differentiation. Before understanding what is differentiation, let us get started with the limits. Okay. So to understand limits, here I have given one example. Suppose you have x square minus 1 upon x minus 1 where x is equal to 1. Okay. If x value is 1, what is the value of this fraction? Okay, so let us directly substitute x value 1 into this. Then we'll get a 1 minus 1 by 1 minus 1, which is 0 by 0. Do we have any definition for 0 by 0? No. So 0 by 0 is undefined here. So if you put directly this x value into this one, it doesn't work. We'll get 0 by 0. So the answer we cannot get, accurate answer we cannot get. So in such situations, what we have to do is we have to go for the limits. So here limits will help us to evaluate its answer. Okay. So first what we will do, assume the x value approaches 1. It is not exactly 1, x value approaching 1. Approaching 1 means suppose it is 0.2, it is little bit far away from the 1 value. Okay. Next take 0.5, it is little bit far away from 1. You take 0.8, it is nearing the value 1. If you take 0.9, it is further nearing the value 1. So what you will do now is take the x value such that it is approaching 1. So I'll start with 0.5, then I'll go to 0.9, then I'll verify its value. The fraction x square minus 1 upon x minus 1, how it changes with the increase in the x value. Okay. So what is limits here? Limits means you take this x value approaching the required value. Here what I want to do, I want to substitute x value 1. So I will start with the smaller value and take this x value approaching 1. 0.9999 means almost it is equal to 1. Okay. Now substitute x value 0.5 into this, then we'll get the answer for this fraction as 1.5000. Now substitute this 0.9 into this, we will get 1.9000. Now substitute the next one, 0.99. The answer will be 1.99. Now substitute this 0.999. Answer will be 1.9990. Okay. So as we keep on increasing this value up to which the value almost equal to 1, you are getting 1.999. So if you look at the pattern, this value keeps on repeating like 1.99999 and so on, 999, isn't it? So what can be the last value? If you keep on doing this, what can be the last value? The last value can be 2. Okay, we cannot confirm, but it appears like the last value can be 2. So if you keep on doing this process, where you will approach? You will approach for the answer 2. Okay. So the limit of this one is 2. Okay. As x tends to 1. This is called x approaching 1 or x tends to 1. You can read that as x tends to 1 or x approaching 1. Okay. So we can say that finally as x approaches 1, the value of x square minus 1 upon x minus 1, it also nearing 2. So the answer can be 2. Answer can be 2. Okay. So we cannot confirm that the answer can be 2 as this x value approaches 1. Now to confirm this, we will do from the other side also. Now from where did we start? We have started with 0.5, then 0.9, then 0.99, then 0.99. So we have started from the left side of the 1. Now we will start from the right side of the 1. Okay, right side of the 1 means 1, 1.5. Now we'll start from the right side of the 1. Right side of the 1 means, if suppose 1 is here, we'll start with 1.5, 1.4, 1.1, 1.01. Like that we'll approach from the right side. Okay. Now in the same fraction you substitute x value 1.5, you will get a 2.50000. You substitute 1.1 now, you will get 2.10000. Substitute 1.01, you will get a 2.01000. So slowly what I am doing here, again I am approaching 1. From the other side of the 1, I am approaching 1. At last what I am getting? 2.00001. So if I keep on doing this process, what I will get? I will get 2.000000000 somewhere 1. So this value is almost equal to 2. So again what we can confirm, if we approach x value to 1, then from this side also we got the limit as 2. The previous case, from this side also we got limit as 2. So that means we can conclude that the value of x square minus 1 by x minus 1 can be 2 when x approaches 1. We are not sure what happens at x equal to 1, but we are sure that as x approaches 1, from this side and from this side, we can say that the limit is 2. We don't know what is exactly at x equal to 1, but we know that as x approaches from this side and as x approaches from this side, we can say that the limit is 2. Okay, this is how we can evaluate such fractions. Okay, now let us verify one more example using limits. So we all know that what is the value of 1 by infinity? We all know that 1 by infinity is 0. So how it is verified? Now let us look at this example, how 1 by infinity is 0. Again apply the concept of limits. Limit extends to infinity. Now what about extends to infinity? What does it mean, extends to infinity? That means as x approaches infinity, what is the value of 1 by x? What is the value of 1 by x? That is actually 0, that we are going to verify now. Okay, now take x value very small, like 1. So 1 by x is 1 by 1, which is 1. Now take x value 2, so you will get 1 by 2 as 0.5. Now take x value 4, it will be 0.25. Now take x value 10, now it is 1 by x is 0.1. So here what I am doing, I am increasing the x value towards infinity. Okay, now take x value 100, now 1 by x is 0.01. Now take x value 1000, if you take x value 1000, 1 by x is 0.001. Now take 10,000, it becomes 0.0001. Like that, if you take 1 lakh or something, 10 lakh or 1 billion, like this, as this number increases, this number is nearing 0. That means 1 by x, as x value increases, the result is approaching 0, isn't it? So when x value becomes infinity, we can say that the value 1 by x is 0. This is where limits can be helpful. Okay, let us move on to next slide. Now differentiation is the first part of calculus. We are going to learn more about the derivatives using graphical method. Okay, suppose we have a straight line over here. Okay, now from this coordinate to this point, whatever raised in value is there, that is delta y. From this coordinate to y-axis, whatever change is there, that is x, isn't it? So whatever change comes in this direction, that is delta x. Whatever change comes in this direction, that is delta y. Okay, we have already learned about slope in the previous lessons. So here what is slope? Slope is what? Delta y by delta x. So finding slope for this graph is very easy. Simply you find out delta y, change in y, change in x. If you know both of them, we can calculate slope. So it is easy to find slope for such straight line. Now the thing is how to find slope for a curved line. If I ask you to find the slope of this curved line at this given point, okay, at this given point, how do you find the slope of this curve? So finding slope of the curve is a complex thing. So here what we will do, this point if you zoom in, this point can be expanded into 2 points. Okay, now this almost seems like a straight line, isn't it? After plotting these 2 points, this almost seems like a straight line. Okay, so for this straight line we can find delta y by delta x, isn't it? But it doesn't stop here. What we will do is we need slope at this particular point only, not between 2 points. Okay, at this particular point if I ask the slope, how do you calculate slope? With the only single point. Okay, this is where derivatives will help us. Okay, to find the slope at a single point on the curve, we use the method differentiation. So let us understand this, how derivatives will work. Okay, now this gap delta y, I'll make it further smaller. Okay, this gap delta y, I'll make it further smaller. In the next step, I will make it much more smaller. In the next step, I will make it much more smaller so that the difference is almost zero. The difference is almost zero. Observe this again. Earlier, the difference was this much. The next step, what I did, I have made it somewhat closer, and I made it much more closer so that the difference, the delta y, is almost zero. So when delta y is almost zero, we represent with the symbol dy. Okay, in place of delta y, we write a dy. Now here also I do the same thing. This gap I will reduce. Now I will reduce it further. Okay, so I will reduce this delta x value so that it almost, this point almost coincides. So now I will get a single point only. No? So this delta x slowly became dx. What is the difference between delta x and dx? Delta x means there is a significant difference is there. Dx means the difference is very small, almost equal to 0. Delta y means there is a significant change is there, but dy means the difference is almost 0. Hope you got the difference between delta x and dx on the delta y and dy. Okay, so what happened here? As I, one moment. So as I changed these values to almost 0, delta y to 0 and delta x to 0, so these 2 points come closer, isn't it? These 2 points come closer and appear as a single point only. Okay, so that means if you make delta y to 0 and delta x to 0, earlier we have 2 points. Now these 2 points come very closer on the given graph. These 2 points will come closer. They come very close such that these two appear as a single point. Okay, now at this point if you plot the tangent, it appears as a single point. Now we can find slope of this point. How we can find the slope of this point? Simply by doing dy by dx. Understood? Earlier the slope is delta y by delta x, but this is the average value. We don't want average value for a given curve. For a given curve, we exactly want at this point what is the slope. I want what is the slope at this point. So what you will do? You simply find dy by dx, which is called derivative of y with respect to x. Okay. So to do this, we have some techniques. We'll look into that. Okay. Now to find a derivative, what is the process we have to follow? Suppose y changes as a function of x. That means as x changes, y also changes proportionally. Okay, so however the function is defined here, the same way the y will change. Okay, now suppose that this x value changes from x to delta x to delta x, then what is the final value? Initial value plus change. Okay, so this is the final value, isn't it? Now, if x changes from x to delta x, x plus delta x, then what about y? Then y changes from f of x to f of x plus delta x, isn't it? Initially y is f of x, now y becomes f of x plus delta x. Understood? This x became x plus delta x because x changes from x to delta x, so the total value becomes x plus delta x. If x becomes x plus delta x, then what about y? That is the question. Okay, so this y changes from initially y is f of x. Now what is the final value? F of x plus delta x. Okay, now let us find delta y by delta x. Actually, our target is to find dy by dx, but first let us understand how to calculate delta y by delta x. Okay, now what is delta y? Delta y is the change in y. What is the change? The final value is f of x plus delta x. This one. The final value is f of x plus delta x minus initial value is f of x. So this is what delta y upon delta x. Okay, if there is a change in x, how y is changing, that is delta y. Okay, now after simplification, make this delta x to 0, then you will get a dy by dx. Yes or no? If you make delta x to 0, what do you call that? Dx, isn't it? So when delta x becomes dx, delta y become dy. So in order to find dy by dx, what you are supposed to do? You are supposed to make this delta x equal to 0. Got the point? Now to understand this much better, let us take an example. Here I have given a function f of x is equal to x square. Suppose f of x is equal to x square. How do you get the graph? For f of x equal to x square, you get the graph somewhat like this, isn't it? So for this, what is dy by dx? What is dy by dx? Dy by dx is how y changes according to the change in x, isn't it? What's the meaning of dy by dx? How the y changes according to the change in the x. So this dy by dx, you are asked to find at this point, suppose. Okay, at this point you are asked to find. How do you calculate that? Using derivatives only, it is easy. Okay, now let us find dy by dx for the given function f of x is equal to x square. Now look here, what is the thing first we have to do? If suppose x changes from x to delta x, then the final value is x plus delta x. Initially it is x, there is a change delta x. So what is the total value? X plus delta x. So this is this. Then what about f of x? If this x changes from x plus this x changes to x plus delta x, then what about f of x? Then f of x changes to f of x plus delta x whole square. Okay, carefully observe what we are doing. Now we got the values. X changed to x plus delta x, then f of x changed to f of x plus delta x whole square, isn't it? Because the function is f of x equal to x square. So here it is x square. Fine. Now what we have to find first? We have to find delta y by delta x. What is delta y here? The delta y is a final value which is f of x plus delta x whole square minus initial value. Okay, initial value is what? F of x upon change in x. Understood what I am doing? I am finding dy by dx, sorry, delta y by delta x, where delta y is the change in y and delta x is the change in x. After this, what is our step? Our step is to make delta x 0, then we can find finally dy by dx. This is what we are going to do now. So let us see what we are doing in the, let us expand this one. So this becomes x plus delta x whole square, that is x square plus delta x whole square plus 2x delta x, because it is in the form a plus b whole square. I have expanded this one. Minus what is f of x? Here f of x we are given that x square. Substitute over here x square upon delta x. So minus x square plus x square gets cancelled. So here we get, let us split this expression delta x square by delta x plus 2x delta x upon delta x. Okay. So now square and delta x gets cancelled. Delta x gets cancelled. So we are left with delta x plus 2x. Okay. So this is what delta y by delta x. Finally we got delta x plus 2x. What is our final step? After simplification, make delta x to 0. After simplification, make delta x to 0. In order to find dy by dx, we have to make delta x to 0. Okay. So now here we have, sorry. So here let us make delta x tends to 0. Then this expression becomes dy by dx is equal to delta x is 0. So we left with 2x. Okay. So how we can read this one? Derivative of y with respect to x is equal to 2x. That is, if f of x is equal to x square, then f dash of x or f prime of x is 2x, or derivative of x is 2x. Okay. Given that f of x is x square, then derivative of f of x is 2x. So this is how we can find the derivatives of the given function. Okay. So let us verify with one more example. Now let us take d by dx of sin x. That means what is the derivative of the given function sin x with respect to x. So let us suppose y equal to sin x. In this, let us suppose y equal to sin x. Okay. So let us verify again, like earlier, let us find out delta y by delta x, and then equate this delta x to 0. Then we will get dy by dx. Same process we will approach like earlier. Okay. Now see, if x changes from x to delta x, then what is the final value? X plus delta x. That is this. Okay. If x changes to x plus delta x, then what about y? Y changes to y plus delta y, isn't it? So what is the total change? Final value minus initial value. Final value is y plus delta y. Initial value is y. Okay. Then here also, RHS side, what is the final value? Final value is sin of x plus delta x minus initial value is sin x. Okay. Now here it is in the form of sin c minus sin d. Okay. Let us assume this term as c and this term as d. Okay. So this expression is in the form of sin c minus sin d. What is the formula for sin c minus sin d? It is 2 cos c plus d by 2 into sin c minus d by 2. So apply this formula to this one and simplify this, we will get this expression. Now what is the next step? Next step is to make delta x to 0. Okay. Now here delta x is 0 and delta x by 2 is very small, isn't it? Delta x itself is 0, and we divide with 2, it will become very small. Okay. So for small angles, we know that for small angles sin theta becomes theta. You remember this point? For small angles sin theta is theta. So since delta x by 2 is small, sin of small angle is that angle delta x by 2. Okay. So we can simply write here delta x by 2, this is anyhow 0, very small. So we can write that in place of cos x, we simply write cos x. And what happened to sin of delta x by 2? It becomes delta x by 2. Why? Because sin of small angle is that angle itself. Understood what I did? So here we have put delta x value to 0. Then delta x by 2 becomes very small. Since the angle is very small, the sin of that angle can be written as the angle itself. Okay. So here in this term cos of x plus delta x by 2, this becomes 0, and what's the remaining value? Only cos x, that is cos x here, and into sin of delta x by 2 has become delta x by 2 whole divided by what is here already, delta x by 2. Okay, so this delta x by 2 gets cancelled. What we got? A cos x. That means derivative of sin x is equal to cos x. Okay, this is how we find the derivatives. I hope slowly you are getting into the concept. Now there are some rules. Every time we cannot do this process, so we better need to remember all these formulas. Okay, so derivative of constant is 0. What does it mean? Derivative of constant is 0. What does it mean? Suppose I asked you to find how the value of 3 changes with respect to x. Okay, suppose here I have a graph x and y. On y axis I am taking the scale as 1, 2, 3, 4. Here I am taking as 1, 2, 3, 4. Okay, now the graph is something like this. The graph is something like this, and the x value keeps on changing. At x equal to 1, what is the y value? It is 3, isn't it? At x equal to 2, what is the y value? At x equal to 2, what is the y value? It is again is equal to 3. At x equal to 3, what is the y value? It is again 3. At x equal to 4, what is the y value? It is again 3. That means as x changes, means as delta x, there is a change in x. What is the change in y? Delta y is 0. There is no change, no. 3 minus 3, 3 minus 3, 3 minus, there is no change at all. But x is changing. 4 minus 3, it changes by 1. 3 minus 2, it changes by 1. 2 minus 1 changes by 1. There is a change in x, but there is no change in y. That means delta y by delta x is equal to 0 when y is a constant. Hope you understood now. If y value is a constant, dy by dx or delta y by delta x is a 0. Isn't it? That means what? Slope is 0. Slope is 0. What is the fundamental purpose of differentiation? To find slope only. Okay. Differentiation will give you slope. Isn't it? So here derivative of y with respect to x is 0 when y is a constant. That is the meaning of the first rule. What is the first rule? For the constant value, if you find the derivative, the answer is 0. Okay. Now similarly, if you find the derivative of x, the answer is 1. That means what? D by dx. One moment. D by dx of x. D by dx of x is 1. Okay. It doesn't mean that dx by dx cancel. It is equal to. It's not like that. It is not like that. It is how you should read this one. D by dx of x is 1. It is not that dx gets cancelled, which is equal to 1. Don't remember like that. It is just a d by dx of x is a 1. Remember this rule also. And what about d by dx of ax? D by dx of ax is a. And next one is called power rule. Power rule will apply in the next future examples. You will understand now. Then, so power rule is what? X power n is equal to, derivative of x power n is n times of x power n minus 1. So what you have observed here, this n comes forward and in the power 1 will be reduced. Okay, so that's why, that is how you remember this rule. Okay, what happens here? Power rule, this n comes forward and in the power 1 will be reduced. Okay, so derivative of x power n is what? N times x power n minus 1. Okay, and what about square? Derivative of x square is 2x. This we already have derived in the previous slide. Okay, what's the derivative of root x? Derivative of root x is 1 by 2 times x power minus 1 by 2. Exponential, it doesn't change. Derivative of e power x is e power x only, and the a power x is natural log a into a power x. Next one, natural logarithm of x, derivative is 1 by x. Okay, so these are all rules we have to memorize. Okay, next, let us apply this power rule we have learned already. D by dx of x power n is what? N times x power n minus 1. Okay, now apply this rule over here. We are asked to find d by dx of x cube. So here in place of n, what is there? 3 is there. Okay, so let us apply this formula. D by dx of x cube is equal to n times x power n minus 1. So here in place of n, what is there? In place of n, 3 is there, x power 3 minus 1. So how much it becomes? 3x square. Okay, derivative of x cube is what? Derivative of x cube is 3x square. Okay, next in the same way, let us find the derivative of 1 by x. Okay, this 1 by x can be written as x power minus 1, isn't it? This goes to numerator, it becomes x power minus 1, isn't it? So here in n plus, in the place of n, the value is minus 1. So let us apply the formula. Minus n into x power n minus 1, minus 1, minus 1. So how much we get? Minus x power minus 2. So derivative of 1 by x is what? Minus x power minus 2. Now what is d by dx of 5x cube minus x square plus 7? So here we have to apply this power rule to the individual terms. This can be split into d by dx of 5x cube minus d by dx of x square plus d by dx of 7. Okay, now d by dx of 5x cube is what? This power comes to friend, isn't it? So 3 times of 5, 15 x power, and in the power 1 will be reduced. That means 3 minus 1 minus d by dx of x square. This power comes to forward, 2 times of x, and in the power 1 will be reduced. Plus what is d by dx of a constant? D by dx of constant is 0. Okay, so this becomes 15 x square minus 2 times of x power 1, simply 2x. So this is the derivative of the given function. Okay, next one. Next rule is product rule. Product rule is also called UV rule. Here I have assumed as F and G, or you can take UV also. Okay, so suppose there are two functions u and v for which you have to find the derivative, and these two are getting multiplied. Okay, product rule, that's what it's called a product rule. If two functions are being multiplied, means there is a product of these two functions, and if you're asked to find the derivative of these two, what's the formula? U v dash plus b u dash. What does it mean? You have to keep first function first function as constant and do the derivative of the next function, and here keep the next function as constant and find the derivative of the first one. Okay, so how to do that you will understand now. Now suppose cos x sin x, I assume cos x as u, sin x as v. Okay, now what is d by dx of uv? D by dx of uv, what is the formula? Keep the first one as it is, first function as it is, and do the derivative of the next one, v dash, plus keep the second one as it is, v, and find the derivative of the first one, u dash. Okay, now so this is equal to d by dx of cos x sin x I can write it as a u. I'll make it constant. I take it as it is and find the derivative of sin x. What's the derivative of sin x? Here in the formula sheet you can see derivative of sin x is cos x. Okay. So here u I have written as it is and v dash is what? Derivative of sin x, which is cos x, plus vu dash. Vu dash means now you keep this v as it is and find the derivative of cos x. What's the derivative of cos x now? Cos x derivative is minus sin x. Cos x derivative is minus sin x. Okay, so this becomes cos square x minus sin square x. So this is the derivative of the given function. d by dx of cos x sin x is what? Cos square x minus sin square x. This is how you make use of product rule. What is product rule? Out of the given function, first function you assume it as u, next one assume it as a v. Okay. Then while finding the derivative, keep u constant and find the derivative of v, plus keep v constant, find the derivative of u. Okay. Now we are done with the product rule. Now move on to quotient rule. Quotient rule is also called u by v rule. U by v rule. Okay. Now here what we have to do is assume this as u and denominator as a v. Okay. The function which is there in the numerator assume it as u. The one the denominator assume as a v. So what is the quotient rule here? Quotient rule is I can write this other way: v u dash minus u v dash upon v square. Okay, here I have used g and f, but for simplicity we can use v u dash minus u v dash upon v square. So first what we have to do, we have to keep this v constant. What is v here? X. So keep this x constant, then find u dash. U dash means what's the derivative of cos x here? Cos x is u. So what's the derivative of cos x? Derivative of cos x is minus sin x. So we are done with the first part, v u dash. V u dash is over, minus u v dash. What is u? Cos x. V dash. V dash means derivative of x. What's the derivative of x? It is 1. Okay. You can refer the formula table. Derivative of x is 1 by v square. V square is what? X square. Okay. So this is the derivative of given function. So to finally what it becomes minus x sin x minus cos x upon x square. This is the answer. This is how we make use of quotient rule. Next one, chain rule. Chain rule is helpful when there are composite functions. Composite function means if there is a function within the function, it is called a composite function. Okay. Earlier it is different. So here the two functions are separate. Cos x and x are separate. Here also cos x and sin x are separate terms. But what if there is a function within a function? Suppose f of g of x. G of x is inside a function and this total one is f of g of x. So there is a function within function. So chain rule will help us dealing with such composite functions. How do you find the derivative of such composite functions? Okay. So the formula of chain rule is f dash of g of x dot into g dash of x. As a formula, it looks quite complicated, but we'll make it easy by looking at this example. Okay, here I have given one example to understand the chain rule in a easy way. Okay, suppose here I have given the question y is equal to sin x square. Okay, if y is sin x square is one function and x square is another function within this function. Okay, so it is a composite function. In such cases, how to use the chain rule to find the derivative? Listen carefully. First, we have to assume this x square as one variable, any one variable. I will assume it as a t. Now what sin becomes? Now what y becomes? Now y becomes sin t. Okay. Listen carefully. How to apply chain rule? First, we are given y equal to sin x square. Now, I will assume this x square as a t. Now, what y becomes? Y is equal to sin t. Now, can you find dy by dt now? It is easy, no? Dy by dt. Differentiating y with respect to t. What is dy by dt of sin t? It is simply cos t. Isn't it? So, the very first step is to find, to assume this x square as a t. Now, we get y equal to sin t. Okay. Now, we have to split this dy by dx into two terms. Since we are dealing with a t here, we have to split this dy by dx into dy by dt into dt by dx. So after dt getting cancelled, again we remain with dy by dx only now. So first we have to rearrange this dy by dx as a dy by dt into dt by dx. Okay. Now what is d by dx of sin t? I will do it here again, so you will understand. It's already written, so I will do it for you. Now we have y equal to sin t. What is dy by dt? So y equal to sin t means what is dy by dt? It is a cos t. Okay. So in place of dy by dt, I can write a cos t into what is dt by dx? What is dt by dx? We have t is equal to x square now. Here we have t is equal to x square, isn't it? So now my second term is dt by dx. So differentiate t with respect to x. Differentiate t with respect to x. What I get? 2x. Okay, x square we have already calculated. The derivative of x square is 2x. So in place of dt by dx, what I can write? 2x. So the final answer is 2x into cos t. What is cos t? T value we have substituted here, which is x square. Now substitute this t value over here. So the final answer is 2x cos, in place of t substitute x square, x square. This is the derivative of the given function y equal to sin x square. Got the point? For y equal to sin x square, what is derivative? The derivative is 2x cos x square. Okay. So in the chain rule, what we have to do? So we have to assume this inside function as t. Okay, inside function as t. Then find the derivative of this whole term. Then do this process. Split the dy by dx into dy by dt and dt by dx. dy by dt you can find in this way, and dt by dx. You know t value, then find out derivative of t with respect to x. Then multiply those two terms, you will get the final answer. This is the application of chain rule. Okay. Or if you want me to do that again, I will do it for you. So given that y equal to sin x square, y equal to sin x square. If you didn't get this in this slide, if you did not understand here, now look here what we are going to do. Okay. So what is our very first step to apply chain rule? Here sin x square is a single function, but here x square is another function. When such composite function is there, we have to apply chain rule. So how to apply chain rule? First assume this x square as any one variable. I will assume it as a t. Okay. So now what sin y becomes? Y becomes sin t. Okay. Now our final target is to find dy by dx. But we don't have variable x here. We have variable t. So what we will do? We will split this dy by dx as dy by dt into dt by dx. Okay. Now can I find dy by dt? Yes. I have y equal to sin t. Then dy by dt is what? For the formula sheet. Then dy by dt is what? Cos t. Okay. Cos t. I am done with this part. First part. In the next part I have dt by dx. Can I find dt by dx? I have assumed t as what? I have assumed t as a x square. Now can I find dt by dx? Yes. dt by dx is equal to 2x, isn't it? We have verified this derivative of x square as a 2x already. Okay. Now I have the value of dy by dt. I have the value of dt by dx. What is dt by dx? It is 2x. Now simply put these two values in the dy by dx expression. That is dy by dt into dt by dx. So what is dy by dt? dy by dt is cos t. Cos t into what is dt by dx? dt by dx is a 2x, isn't it? So cos of in place of t, what we have assumed? We have assumed x square as t. So in place of t, put it back again, x square times 2x. So this is the final derivative of the given function. This is how you apply chain rule. Okay. Now again, here one more example for learning the chain rule. So here what you will do? Here again, it is a composite function. So what you will do now? You will assume cos x as t now. If you assume cos x as t, this one becomes, let us say this whole, okay. If you assume y is equal to 1 by cos x, okay, 1 by cos x. Now assume cos x as a t. So what y becomes now? Y becomes 1 by t. Isn't it? 1 by t. Now, what is our next step? Next step is to split this given dy by dx into dy by dt into dt by dx. Okay. So we have y value 1 by t. We have y value 1 by t. Can we find dy by dt? dy by dt of 1 by t. So this can be written as t power minus 1. T power minus 1. Derivative of t power minus 1. What it becomes? The power comes to friend minus 1 times t power. In power 1 will be reduced. Minus 1 minus 1. So what is the answer? Minus t power minus 2. Okay. Minus t power minus 2 is what? Dy by dt. We are done with the first part. What is next part? dt by dx. Okay. Now what about dt by dx? Now t we have assumed as cos x. Now what we have written here? T in place of cos x we have written. So t is equal to cos x. So what about dt by dx? Differentiating cos x with respect to x, we get a minus sin x. Now we have this term also. Then what is finally dy by dx? It is dy by dt means minus t power minus 2 into dt by dx. What is dt by dx? Minus sin x. So put the value of t over here. Minus of t is what? T is cos x. Cos x power minus 2 into minus sin x. So this minus and minus becomes plus. It will be sin x times cos x power minus 2. Or we can write sin x by cos square x. Okay, this is the final expression. Now, next one in the differentiation is partial derivatives. What is meant by partial derivatives? In the partial derivatives, we hold some variables as constants. We hold some variables as a constant. Suppose here we take one example, volume of a cylinder. What is the volume of a cylinder? It is this cross section area pi r square times height. Isn't it? The volume is what? Pi r square h. Okay. Here volume depends on height and also radius. Pi anyhow constant only. If height changes, the volume changes. Or if r changes, again the volume changes. So here what is that? Volume is a function of both radius and height. Isn't it? Volume is a function of both radius and height. So here first we'll assume that only height is changing, radius is not changing. Then rate of, sorry, then Derivative of volume with respect to height is what? Pi r square times 1. Why it is 1? Because the volume is a function of height only here. R is constant, pi is constant, and derivative of h is 1. Okay, it becomes pi r square. When r changes and h is constant, when r changes, h is constant. Now we keep this h constant, pi is already constant. Then what is the derivative of v with respect to r? Okay, so volume is what? Volume is pi r square h. So constants we write separately, pi times of h. What's the derivative of r square? Derivative of r square is 2r. Okay, so dv by dr is what? Pi h into 2r. Okay, so earlier what we did? Earlier we kept r as constant and found the derivative of h. Now we have kept h as constant and found the derivative of r square, which is 2r. Okay, so partial derivatives means what? Here we hold some variables as a constants and find the derivative of other variable. Okay, now the notation for this partial derivative is del f by del x. Okay, so here this operator is called a del operator. Okay, now to understand this partial derivative is much better, I have given one example over here. Suppose the function depends on all the x, y and z values. If x changes, the function changes. If y changes, and if the function changes. If z changes, also the function changes. Okay. Now the function is given like this: x cube plus 3x square y plus 4xyz. Now when y and z are not changing but x is changing, then what's the derivative of given function? Okay, it can be written as dou f by dou x. Dou f by dou x means y and z are constants. Y and z are constants. X is a variable. Okay, so we will do derivative only for x. So x cube derivative is what? Power comes forward and power 1 will be reduced. So it becomes 3x square. Here in the second term we have both x and y. So here y is a constant now. So 3 times y, 3x square y. What's the derivative of this? Here 3 and y are constants, right, separately. What's the derivative of x? It is 2x. So finally it becomes 6xy. So the second term becomes 6xy. Now in the third term, since we are doing with x, y and z are constants. Y and z are constants. Okay. Now what's the derivative of 4xyz? So here y and z are constant, x is a variable. So 4yz are constants. What's the derivative of x? 1. So it is 4yz. The last term is 4yz. So this is the partial derivative of given function with respect to x. Similarly, we'll find with respect to y. Okay, what's the partial derivative of given function with respect to y? Okay, the derivative of this function with respect to y. So here x cube plus 3x square y plus 4xyz. So since we are doing with y, here x is a constant. So for constant derivative is 0. So here this term 3x square y. 3 and x square are the constants and derivative of y is 1 plus here since we are doing with y, xz are constant. So 4xz write separately. Derivative of y is 1. So the final answer is 3x square plus 4xz. Okay. Now finally we are doing with the z, partial derivative of given function with respect to z. So when we are doing with respect to z, the other terms that they are x and y treated as a constants. Okay. So in this function 3x cube plus 3x square y plus 4xyz. Now since we are doing with z, x and y are constant. So these two terms derivative becomes 0. Now what is the derivative of 4xyz? In 4xyz, 4xy are constants and what is the derivative of z? It is 1. So it becomes 4x times 1. 4xy is the partial derivative of given function with respect to z. Now moving on to finding maxima and minima using derivatives. So in differentiation, one of the important applications is finding maxima and minima. What is maxima and minima? Okay, so to understand that, suppose I have a function going like this. Okay, if I draw the graph for given function, it has come like this. Suppose here, if I ask you to find the slope, and here if I ask you to find the slope, what it becomes? Here I get a tangent, no? So how do you find the slope of a curve? At that given point, draw the tangent. Okay, this tangent will give you slope at this point, no? So here if I draw the tangent, and here if I draw the tangent, these two tangents are parallel to x-axis. So theta equal to 0, and here also theta equal to 0. So what is the slope here? Slope equal to 0. Here also slope is equal to 0, isn't it? What is slope? Tan theta, no? Tan theta. Theta 0 means tan theta 0. Here also tan theta is 0. So at these both points, tan theta is 0. That means slope is 0. So how we can say this is a maximum point and this is a minimum point in the given graph? If you plot the graph, we can say, if you plot the graph, visibly we can see this is the maximum value and this is the minimum value. But if the graph is given like f equal to x square plus 3x plus something like this given, okay, so for this, if you plot the graph, you will understand which is maximum, which is minimum. But without plotting the graph, how you can say at what value of x the y is maximum? Can you say? Understand the point? If you plot the graph, you can say this is a maximum point in the curve and this is the minimum point in the curve. But if I give you the equation, can you say for what value of x y is maximum, for what value of x y is minimum? Can you say that? We cannot know. But using derivatives, we can say at what value of x y is maximum, at what value of x y is minimum in a given curve. This is the one of the important applications of derivatives, finding maxima and minima. So how to find that? Here our problem is what? At maximum point and minimum point, both cases slope is 0. That means if you find dy by dx here, it gives you 0. Here also if you find dy by dx, that gives you 0 only. Okay. Then how to confirm this is the maximum value, this is the minimum value in a given equation? If it is not a graph, suppose the equation is given like 3x square plus 4x minus 3, something like that. For this one, how you can find a dy by dx is maximum or minimum? Sorry, the y value is maximum or minimum. Because the problem is at both points dy by dx is 0. That means using dy by dx, we cannot confirm whether the point is maximum or minimum. So for that, what we have to do is observe how the slope is changing. Okay, here how the slope is changing. Initially the slope is positive, isn't it? Because tan theta is positive. Here positive slope. Then what happened? Slope has become 0. Slope becomes 0. Then here what happened? Tan theta negative. So slope is negative. So near this maximum value, what happened here? Initially slope positive, then 0, then negative. Once again, observe carefully. At this maximum point, what is happening before this maximum point? Slope is positive, then here slope becomes 0, then it became negative. So you should know what is happening before this point and after this point. Before the maximum point, slope is positive. At the maximum point, slope is 0, and after the maximum point, slope is negative. Okay. Now coming to minimum point. At this point, minimum point, before this minimum point, slope is negative. See obtuse angle. Obtuse angle means slope is negative. And at this point, at this minimum point, slope is 0. After this point, slope is positive. Okay, so it is changing from negative, 0 and then positive. You observe the fundamental difference. Near maximum value, it is changing from positive to 0, then to negative. But here, negative, 0, then to positive. So this is how we differentiate what is happening near maximum value and what is happening near minimum value. Okay, so dy by dx at both places it is 0, means slope is 0 near maximum and minimum. Okay, slope is 0 near maximum and minimum. But we can verify how the slope is changing. How the slope is changing? Near maximum value it is changing from plus positive, 0 and then negative. Near minimum value it is changing from negative, 0 and to positive. So dy by dx is not sufficient, so we have to find d square y by dx square, slope of the slope we can say. Okay, so dy by dx is a slope, d square y by dx square is what? How the slope is changing, dy by dx, how the y changing with respect to x. What is d square y by dx square? What is d square y by dx square? How the slope is changing. D square y by dx square gives us an idea about how the slope is changing. Got the point? To confirm whether it is a maximum or minimum point, we have to see how the slope is changing. If the slope is changing from positive, 0 and to negative, it is a maximum point. If the slope is changing from negative, 0 and to positive, it is a minimum point. Okay. Now dy by dx is a slope. It is 0 at both the points. We cannot confirm. Okay. Now what we have to do? We have to find d square y by dx square. That means how the slope is changing, that can be known by d square y by dx square. It is also called double derivative. Okay. Now if d square y by dx square is greater than 0, that is minima. Okay, here you see after this point what is happening. After this point the slope becomes positive. Okay, so if d square y by dx square is positive, the value is minima. In the curve the value is minima. Okay, now if d square y by dx square less than 0, the value is maximum. So here what is happening? After this point the slope is becoming negative. Okay, so slope becomes negative means the point is maxima. Okay, this is how we can find out in a function whether it is a maximum or minimum by finding the d square y by dx square. Okay, if d square y by dx square value we get greater than 0 means the point is a minimum, and if d square y by dx square less than 0, the point is a maxima. Okay, now look at one example. Y is equal to minus 2x square plus 4x plus 3. This is what I am talking about. If you are given function like this, and can you find at what value of x, y is maximum, and at what value of x y is minimum? Can you say that? Simply by looking at this equation we cannot know. So this is where our maximum minima concept is helpful. Okay. Now first what we have to do? We have to find where slope becomes 0. Okay. For a given function, first we have to find where slope becomes 0. Where slope becomes 0? Where slope becomes 0? Here also and here also. Near maximum and near minimum, slope becomes 0. So first we have to find the dy by dx value for the given function. So let us find out dy by dx. Dy by dx of minus 2x square is minus 4x plus dy by dx of 4x is 4. Then x equal to 1. Okay. So for value of 1, the y, the slope of the dy by dx becomes 0. Okay, so x value is 1. Okay, now what is the coordinate? To find out the y coordinate, substitute this x value in the given equation. Now we got x value. To know the y coordinate, substitute this value in this given equation. We get y value 5. Now that point on the curve is 1 comma 5. Suppose the graph is not for the given function. Suppose this point is 1 comma 5. Is it maximum or minimum? How to confirm? We have to confirm by taking double derivative. Okay, single derivative will tell us only the slope is 0. But is this point maximum or minimum? How we can confirm? We can confirm only by doing the double derivative of it. Okay. Now let us find the double derivative of that d square y by dx square. Okay. We already have dy by dx. How much is that? Dy by dx is minus 4x plus 4. Minus 4x plus 4. dy by dx is equal to minus 4x plus 4. Now what is d square y by dx square? Means do the derivative once again. For 4 derivative is 0. So minus 4x is minus 4 times of 1. Okay, it is minus 4, which is less than 0. If it is less than 0, d square y by dx square is less than 0. What is that? Maximum or minimum? Less than 0 is a maximum. Okay, so this coordinate 1 comma 5, this coordinate 1 comma 5 on the graph is a maximum value. Okay, now this is the end of basic differentiation we require for a physics. Okay, that's it for the day.